The thing that becomes evident with any CNC or automation project very quickly is that there are a lot of wires. Today we're going to get all of these wires routed, tucked away, and more importantly, protected from damage. We're going to get the electronics in a box, and hopefully we'll get this thing running end to end. Welcome back to Cloud 42. I'm James. Well, we are back on the surface grinder automation project today. You'll remember last time we looked at some of the coding with AI tools, and today we're going to get back to the electronics and try to get all of these cables tucked away safely and installed in their permanent homes so that we have a machine that's not just functional and running under power, but actually ready to go and ready to use for real work. There are lots of considerations when doing something like this on a machine like this. We've got two motors down here in the front. We've got a motor up there on the y-axis, and all of these cables have to get to the controller safely. So we've got power supplies for the motors. We've got the microcontroller. We've got all of the electronics for the control panel, which isn't mounted here right now, but those have to go back to the microcontroller as well. And all of those electronics need to be in some kind of enclosure to protect them. And then once we've got that, we got to figure out where we want to put that enclosure. Now, the obvious place to put the enclosure on this grinder would be over here on the left side of the pedestal. The electronics that run the motor and the spindle and the lubrication system are all over here on the right, so that side isn't available, but there is a nice big blank panel here on the left. The problem with that is that the grinding wheel spins and throws the grit in that direction. So that is the dirty side of the grinder, and I really don't want to put the electronics over there. I'm going to use a NEMA 4 enclosure that's sealed. Hopefully I'm going to get away with that and not have to put ventilation in it. But if I do, I really don't want it over on the dirty side of the grinder. I want it over here on the clean side. So I think rather than trying to mount the electronics on the pedestal, I think I'm going to go ahead and put those up on the wall behind the grinder. They can stay up high, they can stay on the clean or relatively clean side of the grinder, and that should leave them much better protected. This is the box that I'm going to use for the electronics. This is a NEMA 4 enclosure, 16 by 16 by 8 inches. And it's a welded steel box that has a gasketed door. So when this is closed and latched, it should seal dust out and it should protect the electronics inside. Now, I've bought NEMA enclosures like this from different suppliers over the years for different projects. And if you've done that, you know that these boxes can be very expensive. From a typical US industrial supplier, a box this size is over $200, sometimes $250. This box from Vevor was under $70. I think it was $69. And so for a price like that, I thought it was worth a shot. I had no idea what the quality would be like, but I'm pleasantly surprised. And no, this is not sponsored. They do contact me on a regular basis asking if they can sponsor videos, but I haven't responded to them, and this is not a sponsored video. But I figured for $69, that's a pretty nice price. We might as well try it and just see. And honestly, it's pretty good. In terms of kind of the weight and rigidity of the box, it seems about the same. There are a few differences. They're using carriage bolts with nuts to stand off the subplate rather than actual welded studs, which I don't think is a problem at all. But other than that, this thing seems really good. One feature that I really like about it is that they have a cutout in the bottom, and then it comes with a gasket and a steel panel for connectors. So you can take this out, go machine this in your machine tools, put in whatever connectors you need, and then mount it back on the box. So you're not trying to cut holes in the box itself. And these are typically very difficult to cut. And things like, jigsaws and drills, it's a mess, especially when you're trying to get the whole box into a machine to do that. This is a really nice touch. Now, of course, I'm not going to use this at all. I 3D printed a panel that will fit in this space with the gasket that will hold all of the connectors that I need. This panel is printed in Bamboo Lab PA high temperature carbon fiber. So this is their high temperature carbon fiber nylon. And I am trying out a new printer. I would normally print something like this on the X1 Carbon, but I actually have an X1E now that they sent over for testing. And I gotta say, I am impressed. The X1E's got a bunch of features for enterprise use, like wired Ethernet and some different security aspects to it. But the thing that I really wanted to try out is the heated chamber, and I've got to say it is fantastic. I actually printed one of these on the X1 Carbon, and as usual, when you start printing something in nylon this big, you get just a little bit of curling around the edges. Let's see if I have it here. So here's the one printed without the heated chamber, and you can see there's a little curling around the edges, and so this part is not very flat. This particular case, it's flat enough. But when you compare that to the one that came out of the X1E with the heated chamber, it is just a night and day difference. So I am really pleased with that. So we've got the connectors here for the control panel. This is for the Ethernet pass-through, and we've got the two connectors for the M12s, and then we've got a place here for a PG11 cable gland. And by the way, I just spec'd those threads, modeled them, printed it, and that fit on the first try. Like I said, I am very, very impressed with this printer. Now, this structure here in the middle is a cable clamp for the power and the servo control wires. Instead of mounting connectors on here and putting yet another connector in line, I decided to just bring the cables in through the panel and land them on the devices inside. So the cable goes through, and then there's a separate little plug here that drops into place and clamps down and holds that cable in position. So I can bring in all three servo wires and all three servo power cables. This clamps down and provides strain relief for the cable, and it's secured with two screws that go in from the bottom. So we'll try that. I think this is going to work, so then this can just run up inside the panel and land on the power supply, or land on the power bus, or on the controller, and we'll see how that works. If it works, great. I've just saved myself a whole bunch of trouble. If it doesn't work, it's easy enough to just print a different insert panel here for the box that has connectors in it, and I can cut the cables and crimp in new connectors. Now, like most NEMA enclosures, this actually comes with a subplate. So it's a galvanized steel sheet metal plate that mounts in the bottom of the box, and I've already taken that plate and mounted all of the electronics that I need onto it. And then this will just go into the box, mounts on those 4 studs, and so when this is mounted on the wall, first of all, I can mount the box on the wall without the weight of this in it while I'm handling it, but then I can take this panel in and out so I can do my wiring or any maintenance work off the wall here on the bench. To design the layout for this and make sure that everything was going to fit, I actually modeled this all up in Fusion, and I printed out a diagram with the locations of all the holes that I needed in the sub panel, whether they were threaded, what size they were, and all the dimensions. And then I went ahead and threw this thing on the milling machine and drilled and tapped all of the holes so that I can just screw down all of the components onto the sub panel, and I've got an easy package that goes in and out. And more importantly, I knew what size of box to order, and I knew that everything was going to fit on the first try. Vevor does not publish 3D models of their boxes on the website, but if you email their support, they will actually send you one. So that's what I used to lay all of this out. And I tried to put as much as I could on DIN rails. So I've got a 35 millimeter, I don't even remember, a standard DIN rail in the back here, and I've got the mount for the clear core. I 3D printed my own mount that I designed for the encoder adapter. I've got a breaker here, I've got some terminals to distribute ground, and I've got a 24-volt power supply. And those all just lock into the DIN rail, which is nice and convenient for mounting, you know, any of a number of different industrial components that you might need. Then up here at the top, I've got the IPC5 power supply. This is the power supply for the clear path servos. Now, normally they would prefer that this be mounted vertically, but I just could not find an orientation in the box that would make everything fit, especially since I switched over to this vertically mounted DIN power supply. It is acceptable to mount it horizontally, so I did. I don't feel great about it, but I did it anyway. And this is their bus for the 72 volt power for the servos. And this normally comes as just a bare PCB on a mount, and I 3D printed a case to go around it because this was knocking around on the floor for a while I was prototyping. So I've got this all laid out. I've got these nice finger ducts around the sides. And these, of course, come with lids that'll snap on when I'm all done, give me a way to hide the wiring and keep it nice and neat and contained. So now it's just a matter of going around point to point and wiring everything. And I think I'm just going to start with the DC power. So we'll come off of the power supply, bring that around, and land it on the power connector of the clear core. Now for all of these connections, I'm using ferrules on the end, just to keep the stranded wire from fraying. So those just crimp on, and then to label these, I'm using printable heat shrink tubing. Nice and simple. Okay, that's one connection done. I have many more to go. Get the rest of the power wiring in here, get the AC wiring in here, and then bring in this connector panel and drop all of the connector wiring, and I will be back when that is done. I spent an hour or two here in the shop finishing up all of the wiring, and here is the final result. The first thing I want to call out is that I really made an effort to separate the high voltage AC from the low voltage DC lines. Now, I don't think it's in the end going to be that big of a deal, but some of these things, especially the analog inputs here for these selector switches, I wanted to make sure that that was just as far away from the high power, the high voltage AC stuff as I possibly could. So the way this is going to work, the AC is going to enter through this strain relief down here at the bottom. The ground will land on this stud, which is attached to the plate, and then the two hot wires will come around and go into the top of the breaker. And yes, I really should color this white wire black because it is hot. Then the breaker feeds down to feed the two power supplies, and then I've got a couple of terminal blocks over here to distribute the ground. So this is the protective earth ground, and it goes to both power supplies, and it goes to the clear core. Now technically the clear core has an aluminum back and has a DIN rail mount, and the DIN rail is attached to the back panel, which is grounded. So that is sufficient for the protective earth ground, but they did provide a terminal, so I went ahead and connected it just to be sure. For all the rest of the wires, I brought them in and brought them around this side, and they land on all of the inputs and outputs of the, well, I guess all the inputs of the clear core, the inputs over here for the encoder, and the extra wire. Rather than trying to cut these exactly to length, I just went ahead and looped the extra wire inside these little finger ducts, figuring that I may want to move something around at some point in the future, and having that extra wire here is not going to hurt anything as long as it's not excessive, and as long as I don't have loops of that wire laying next to the AC lines. So I got the 72 volts from the power supply going down to the power strip here. So in order to connect the servos, those will all come in through the little clamp here in the bottom panel. The servos will just connect directly to the clear core. The power will come around and connect to here. And with the covers snapped on the finger duct, all of our crimes are hidden. Incidentally, I did get some comments in one of my previous videos about the crimper that I was using for some of my ring terminals. And based on some of those suggestions, I did pick up a proper insulated terminal crimper. So I do listen. To mount the box on the wall, there are 4 holes provided in the back. Unfortunately, These holes are not on any particular spacing and they don't line up with anything. They're certainly not going to line up with the studs that I have in the wall. So to mount this, I'm going to use Unistrut. If you've never used this before, this is Unistrut. It's a channel. It's 1 5/8 inches in each direction. I'm sure in other parts of the world they have these with metric dimensions. But this is a strut that I'm going to mount on the wall that's going to span across 2 studs. So I'll screw it into the studs on each end and then mount the box to the strut. To mount the strut to the wall, I'm going to use what are called structural connector screws. And these are screws that are designed for construction. They have a tooth in them so that they will cut directly into the stud. No pre-drilling is required. They've got a nice big structural head, and these are rated to carry structural loads. So you would use these in new construction when you're putting, steel brackets and joist hangers and those sorts of things. But these are perfect for mounting things to stud walls because you can drive them in with no pre-drilling, and they are rated to hold significant loads, certainly way more than we're going to use here. And I'll just throw a washer on it, and then we'll run that through the strut. Scratch that, we'll use a fender washer, and we'll run that through each end of the strut to mount these to the stud. Then to mount the box to the strut, we have little snap-in nuts, and these nuts just drop in, rotate a quarter turn, and then provide threads. Then the box will mount to those threads just using a 1/4 inch bolt. I chose 1/4 inch just because that's the size of the hole that's in the back of the box. I'd much prefer to use something larger like 3/8 or 1/2 inch, and other boxes have holes that size, but this one is 1/4 inch or probably 6 millimeters. So that's what we're going to use. And of course, these can move left and right on the strut, so we can position the box wherever we need it. And the strut itself will provide the structural support between the studs. Getting this on the wall was a lot harder than I thought, just because I can't stand under it, so it's hard to support the weight. I have to lean out, hold it up. But as you saw, I did get it installed, and it is firmly mounted to the wall. I think this is where I'm supposed to say, that's not going anywhere. I've got the power wire coming in and hooked up inside the box. The other end isn't hooked to anything yet. It will be shortly. And I think everything else is ready to go. We just need to bring in and land the power wires and the servo wires, but I need to get the wiring on the grinder itself sorted out before we do that. The one part of this project that has kind of stymied me for a while is figuring out what to do with the cables. Obviously, these cables come up to the servo motors that are motors that are mounted to the saddle up here. So those move in and out. So just finding a good place to strap these wires down where they don't move isn't an option. They're going to have to flex somewhere. And I had originally been thinking they would just hang down on the front of the grinder, but I really don't like that. They're exposed, they're ugly, and they're subject to damage there. And it's not just these 4 cables for the 2 servos and then the 2 power cables for the servos. There are also going to be the cables for the control panel. So there's at least 3 cables for that. And then depending on whether I end up using the limit switches up here or not, there's going to be 2 more cables for those. And they need to go somewhere, and I don't want them big, draped over the front in a big bundle. So looking at the grinder for a while, I discovered there actually is a route that these cables can take. They can go down under the saddle and then go all the way back here and out the back. There is a straight shot all the way through with enough clearance for the cables, And there's a nice little steel shield on the side there that's meant to keep grinding dust out of the slides. And there's plenty of room there to put in a wire duct. So this is the wire duct that I'm planning on using. This is just a cheap plastic finger duct that I bought from Amazon. This is probably, what, 1.5 inches. So it's probably 40 millimeters by, I don't know, 20 millimeters, 15 or 20. And so this should hold all of these cables plus a few more, and I should be able to mount this on the side of that shield. Now I could pull it out to do that. There are screws, but you have to kind of run the saddle back and forth to get at all of them. And I don't think I actually have to do that to mount this. This finger duct came with this double-sided adhesive. This is the clear stuff that just has backing on one side. I'll put a strip of that down this, stick it onto that shield, and that should be sufficient. I use this stuff for all the wiring on my plasma table, and it's been that way for a couple of years and hasn't moved at all. If it eventually is a problem, I can always pull those shields out and find a better way to attach it, but I think the double-sided tape is going to work for now. Unfortunately, you're not going to be able to see me do this, so let me get this stuck on and get some cables run through it, and I will see if I can get my cell phone under there and get some shots of it installed. The beautiful thing about doing it this way is that these cables have no flex point at the front. They're run all the way to the back of the saddle where they come and fall off the back of the machine. So the only motion is in that loop from the back of the machine up to the cabinet on the wall. You get a nice long loop of cable, and that can just gently move as the saddle moves back and forth. And that should be the only motion in any of the cable harness on this machine. I got all of the cables routed through the wire duct. There was plenty of space in there, and it is a nice, neat, tidy installation. I don't anticipate having any trouble with that. It's up out of the way. It's not sitting down on the surface where even if coolant or any other kind of fluid or oil or anything leaks out down there, the cables are going to be held above that. They're protected from anything flying and hitting them directly. And the saddle will move the full travel without them hitting anything. And we've got nice, neat cable loops just hanging behind the machine. So I don't anticipate any trouble. That actually worked out way better than I expected. And then I've got all the cables landed up here in the box. This is the power cable. It's connected. These are the power cables for the servos. They route up around the side to the power strip. And then the 3 control cables for the servos come up and land directly on the clear core. And then I've got the cable clamp tightened down with 2 M5 screws, and that has gripped these beautifully. I think that is going to work perfectly. And if I have to move anything, it's pretty easy to just unplug those 6 cables, take out those 2 screws, and they just drop out. I will look into getting some wire loom to go around these just to make them look a little nicer and not see as much cable out here, and I might end up re-terminating these to exactly the length that I need. But for now, this should be ready to run. I'll have to program the clear core because this isn't the same one that I've been using for the programming on the bench. To get the 240 volt power to drive the control system, I'm going to steal it from the control panel right here on the grinder. This grinder was wired originally with 2 contactors, one for the spindle and one for an optional dust collection system. I don't currently have a dust collection system on this, but there was a knockout here in the bottom and there was already a cable gland in place to bring in the cable for that. So I just brought in the cable from my control system, tied it down onto the safety ground here, and tied the 2 legs to the R and T legs of the 3-phase power. Those are the pass-through phases, so that's the 240 volt power from the wall that's always present, but of course I have the safety switch down here, the 3-phase monitor that won't allow any of this to switch on unless the phase converter's on and all 3 phases are live. But if all 3 phases are live and I switch this on, I can now use the switch for the dust collector to engage this second contactor and take the 240 volt pass-through from the wall and route that up to the control panel for the power supplies. So I might relabel this. I might just leave it as a surprise, but flipping on the dust collector switch will turn on the servo control system. Oh, and it is worth noting there is an overload. This is not just a contactor, this is a motor starter, so it has an overload on it. I don't actually know how this is set. I really don't think the power supplies for the control system are going to pull enough power to trip the overload, but if they ever do, I can just remove it, or I can adjust it, or I can replace it. It doesn't really matter. I don't actually need it. Well, I think that's it. I think all the wiring is in place. I don't think there's anything else to check. I did check and make sure that we were actually getting power to the clear core. And once I had power to the clear core, I plugged in a laptop and programmed it. I think we are ready to run. Let me switch on the phase converter and let's give it a shot. Okay, we've got power to the grinder. And I see I've got oil in the sight glass. Let the wheel spin down there. Safety glasses. Okay, let's power it up and see what happens. Okay, I just heard the motors engage. I've got my splash screen and I've got my controls. Take off the e-stop, select the x-axis and jog. Well, that looks good. So that's the coarsest setting, which is 1 inch per revolution of the hand wheel. I mean, I can switch it to metric too. And there's the finer one. Okay, let's try Z, in and out. That works. Finer feeds look good. And let's try Y. Bring the head down 1 inch. Nice. Because of the extreme reduction and the fine resolution on the y-axis, it's easy to get the MPG way ahead of the machine. But I've got it set up so that the e-stop here will stop the motors, and it's actually using the functionality inside the clear core control system, not actual code that I wrote, but the actual interrupt system to shut down the motors. But worst case scenario, I can slap the e-stop switch down on the grinder and that kills the power to absolutely everything, including the spindle, the clear core, the servos, everything. So the way this works though, if I give this a few turns so that it's got a long move that it's in progress, I can just hit the e-stop and it stops. And then when I release the e-stop, it's ready to move again. And it keeps track of where it was. And we don't lose the position when we go through the e-stop cycle here. So that's a good way to stop it if something really bad is happening. But we've got the big e-stop switch down there if we just need to kill the power to everything. Well, I'm happy with that. I don't have the grinding cycles programmed. That is the very next step. But this is really good. Let me bring the camera in closer so you can see what's happening here on the display. One important thing to note is that the DRO is actually reading out the actual position of the machine at all times. So you can see if I go faster than it can go, it continues showing the position of the machine as it moves. So I opted to go in that direction, actually show that rather than showing the target you're moving to, so that you always know exactly what's happening. There's definitely a lot more work to be done on the HMI. Don't worry, it's going to look better than this when it's done. It works. This is the part of the project that starts to get exciting. We've actually got everything on the machine. It's all wrapped up. It's in a condition that I really am happy with mechanically and electrically, and now it's just down to the software. And there's lots of work still to do. I've already done quite a bit more than what you've seen in this video. This video is just focused on getting the thing on the machine and actually running. I am just getting ready to start working on the grinding cycles, and then we should be able to actually take this thing for a run and actually grind something. And I am really looking forward to that. As I'm going through the software development process, I am sharing some of the details in the forums for patrons. So if you're interested in that, you can check that out. Or if you're just interested in helping to support the channel, Patreon is the best way to do it. Well, I got to get to work on some software, and hopefully you will be seeing this again actually running and making sparks very, very soon. Thank you for watching.